This is Mr. Beck Does Your Homework, Physics Homework 23, questions number 9, 10, 11, 12, 13, and 14. 4 resistors are connected to a battery with a terminal voltage, meaning the battery's voltage is 6 volts, as shown in the figure. Find the equivalent resistance of the circuit, answer in units of ohms. Well, I come out of the battery, I actually come out this way, I'm going to go this way. Out of the battery through this resistor, then it splits. When it splits, I've got these two branches that are parallel to each other, but on this branch I have 2 resistors that must be added together in series. So these two are series. So the first thing I'm going to do is I'm going to combine 2 resistors in series, meaning I simply add them together. So I'm going to replace them with an equivalent resistor. So I have a resistor of 30 ohms and another resistor of 66 ohms. So this single resistor here will replace those two. And it's simply going to be, for me, 30 plus 66, whatever that total is. Okay, I'm going to call that R1. So now I've got a resistor here that's R1. I've got another resistor here and another resistor here. They might look all parallel, but they're not. This one it must go through, then it splits and chooses between 62 or this R1. So these two are parallel to each other. So what I can do is I can put a resistor there, a single resistor, to replace those 2 resistors. And that single resistor is going to be the parallel combination of the R1 and the 62. So this parallel combination is going to be 1 over, I'll call it R2, equals 1 over R1 plus 1 over 62. So there's my parallel combination. So this resistor, 1 over that resistor, is going to be 1 over this total plus 1 over 62. So 1 over 62 plus 1 over this, make sure to inverse it, and you'll get a resistance here, which I'll call R2. Now I've got current that's flowing through this resistor and through that resistor. So I have to add them up in series. So I'm going to take another resistor combination. I'm going to combine them. Let me combine them this way to get a single resistor. And that single resistor is simply going to be this one that I called R2 plus my 17 because they're in series. So this one is going to be 17 plus R2. That's going to be my equivalent resistance of the circuit. That is the answer to question number 9. Question number 10 says find the current in the battery. Well, the current in the battery, that's my total current from the circuit, is going to equal, through Ohm's law, the voltage of the battery divided by the total resistance. Well, the total resistance I found for question number 9, so I know that. The voltage of the battery they give me, for me, it's 6 volts, so I know that. If I know that and that, I get my total current in the circuit. It's just the voltage of the battery divided by this total resistance from number 9. Find the current in the 30 ohm resistor. Well, let's see, which one was the 30 ohm resistor? Ah, there's the 30 ohm resistor. So this resistor I need the current in. To get the current in that resistor, I need to know how much current is going down that branch. Well, I know the current leaving the battery. I know the current going through the 17 ohm resistor, but that current is going to split between this branch and that branch. So I'm going to need to know the current. The way I'm going to do that is if I can figure out the voltage here, the voltage here is going to be from here to here. So I go 6 volts across the battery. This is going to be part of it, and from here all the way to here is going to be the remainder of it. So let me look at this one, right? So if I have so many volts here, then I'm going to have so many volts here. So this current here is my I total. This is also my I total. My total current is going to be flowing through this resistor. So if I know R2 and I total, I can get the voltage here. So I have my I total. I will go back and look what I had for R2, because here my current there is going to be, my voltage there is going to be the current total times R2. That's going to give me the voltage across R2. If I know that voltage, I also know this voltage, which means I also know this voltage. So now I can find from R1, I'm going to know the resistance of this resistor. I know the voltage of this resistor. That's the same as this voltage, because this voltage is the same as this voltage. So if I measure from here to here, it's the same as if I measure from here to here, so I'll know that voltage. So the voltage across R2 is going to be the same as the voltage across R1, and the voltage across R1 will give me that combined with the resistance of R1 will give me the current down this branch. So the current through R1, this equivalent resistor, is going to be the voltage of R2, because that's the same as this one, it's the same as this one. So it's the voltage of R2 divided by R1. That'll give me the current through R1, which is going to be the same as the current down this branch. So the current down this branch is the current down this branch. So that will give me current in the 30 ohm resistor. Find the power dissipated by the 66 ohm resistor. Well, here's my 66 ohm resistor. Once I know the current from number 11, that current is flowing through this resistor, and I know that P equals I squared R. So if you know the current from number 11, square it times my 66. That's going to give me the power in this resistor. Find the power dissipated by the 17 ohm resistor. That's that one. That's easy. I take my total current and that resistance, and again I'm going to do P equals I squared R. So that'll give me 17. And find the power dissipated by the 62 ohm resistor. Well, earlier I figured out the voltage across this. That's the VR2 that I got over here. That voltage is across the 62 ohm resistor. So because that's the voltage here, and that's the voltage here, and that's the voltage here. So that voltage across the 62 ohm resistor is going to help me, because power is also V squared over R. So if I know the 62 ohm resistor, that's my R. My V is going to be the voltage that I got for R2 way long ago.